Right, welcome back to 30 Days of Physics with Miss B, and we're moving right along into work, power, and energy. Energy is the ability to do work. Energy is equal to force times displacement. The SI unit of energy is the joule. Work is the product of force and distance moved in the direction of the force. Work is equal to force times distance. The SI unit of work is the joule. Power is the rate of doing work or of using energy. Power is equal to work done divided by time. The SI unit of power is the watt. Here are some forms or types of energy. We have thermal, light, sound, kinetic, potential, electrical, and nuclear. Thermal energy. This type of energy is heat energy stored within a body. Light energy. This type of energy is an electromagnetic wave which has a speed of 3 times 10 to the 8 meters per second and does not require matter to travel. Sound energy. This type of energy requires matter to travel by causing air particles to vibrate. Kinetic energy. This type of energy is the energy of a moving object. It may be determined by the equation EK is equal to mv squared divided by 2. M means mass in kilograms and V means velocity in meters per second. Potential energy. This type of energy is stored energy within an object due to its position, gravitational, physical, elastic, or chemical state. It may be determined by determining the product of mass in kilograms, gravity in meters per second squared, and height in meters where EP is equal to mgh, and G, unless otherwise indicated, has a value of 10 meters per second squared. Electrical energy. This type of energy exists in electrical circuits where energy is transferred through wires in an electrical circuit. Nuclear energy. This type of energy is stored within the nucleus of atoms. Energy sources for electricity. There are non-renewable and renewable sources of energy for electricity. Non-renewable sources are fossil fuels and nuclear power. Fossil fuels include coal, oil, and natural gas. These types of sources get used up over time. Their use also produces waste that pollutes the environment. Renewable energy sources are solar power, hydroelectricity, tidal power, wind turbines, geothermal energy, and biofuels. These types of sources don't get used up over time, nor do they produce any waste that can pollute the environment. The principle of conservation of energy states that energy cannot be created or destroyed, but can be transformed from one type to another. Examples of energy transformations. An electric fan being turned on transforms electrical energy into kinetic energy and then sound energy. If a fruit falls from the tree, then it goes from having potential to kinetic energy to thermal, then sound, and eventually potential energy, again if it doesn't rebound. A fish eats other fish that are smaller than it and gains chemical potential energy. This energy then transforms into kinetic energy, thermal, and sound as the fish swiftly swims away. Lighting a candle involves a chemical reaction. Hence, it starts off with chemical energy being converted to thermal and light energy as the candle burns brightly. Efficiency. The efficiency of a transfer of energy is a measure of how much energy is transferred usefully. The efficiency of a system is never 100% because heat is always lost to the surroundings due to frictional forces. This type of energy is referred to as wasted energy. Efficiency is equal to work done on load divided by work done by effort, or energy output divided by energy input. Please note you would multiply each equation by 100 to determine the percentage. Let's try some questions. How much energy does it take little Johnny to move a 10-kilogram bag of grafted mangoes 20 meters to his back door from his neighbor's mango tree? Take gravity's value as 10 meters per second squared. Pause the video to try this awesome question. Well, if energy is equal to force times distance, then you just plug it in. Remember, you have to convert the mass of the mangoes to weight. Okay? So you have to multiply by 10 meters per second squared, and then you multiply by 20 meters. You get a whopping 2,000 kilogram meters squared per second squared, which is equivalent to 2,000 joules. You may write 2 kilojoules if you wish. Let's try another question. A 45-gram golf ball rolls off of Nancy's bed and falls from a height of 80 centimeters onto the floor. How much potential energy did the ball possess before falling? You may pause the video to answer this awesome question. Well, if EP is equal to mass times gravity times height, you simply substitute for all of those variables. Do remember, you have to compute in SI units, so you have to convert 45 grams to kilograms, and you also have to convert 80 centimeters to meters. Simply divide by 1,000 to get your kilograms, from grams to kilograms, and simply divide by 100 to go from centimeters to meters. EP, as in potential energy, would then be equal to 0.36 Newton meters. This is equivalent to joules. Using your answer from the previous question, determine the velocity of the golf ball. Try to answer this awesome question on your own. Please note that here, EP is equal to EK, as in potential energy would be equal to the kinetic energy. Transformation of gravitational potential energy to kinetic energy is common. It happens every time something falls. Equation EP and EK can be used to determine the velocity of a falling body if you assume there is negligible air resistance. So if EP is equal to EK, then mass times gravity times height is equal to mass times velocity squared divided by 2. 0.045 kilograms times 10 meters per second squared times 0.8 meters would be equal to 0.045 kilograms times velocity squared divided by 2. With a little bit of transposition, you get this setup right here. The masses, of course, will cancel out since you're dealing with the same object, and you will get 16 meters squared per second squared to give you velocity squared. Now all you have to do is find the square root of velocity to get v by itself, and you get 4 meters per second. What is the power rating of an engine which transfers 30 kilojoules per minute? Pause this video to try this awesome question on your own using power is equal to energy divided by time. Remember, the SI unit of power is watts, which is equivalent to 1 joule per second. So we have to convert the 30 kilojoules to joules, and we have to convert that 1 minute into seconds. You divide 30,000 joules by 60 seconds, and you get a beautiful 500 joules per second, which is equivalent to 500 watts. A load of 500 newtons is raised 0.2 meters by a machine in which an effort of 150 newtons moves 1 meter. What is A, the work done on the load, B, the work done by the effort, and C, the efficiency? Breathe in, breathe out. It is not that hard. Let's go. You may pause this video to answer the wonderful question or just let it run on. A, work done by load. Remember, work done is equal to force times distance. So if the load moved 0.2 meters, you would just multiply 500 newtons by that 0.2 meters. You get 100 Newton meters. Now you're looking at work done by the effort. You multiply 150 newtons by 1 meter. And it's nicely broken up in the question for you. And you get 150 Newton meters. To determine efficiency, simply put the smaller number over the bigger number. You can't get more than 100%. Okay? So you divide 100 Newton meters by 150 Newton meters. You multiply all of that by 100 and you get 67%. Alright guys, I want to thank you for watching another episode of 30 Days of Physics by Miss B. Day 11. See you around for day 12. Bye!